This is Unit 1, Topic 7. Hello, and welcome to the BMC Quick Course series. This module will describe the dynamic checkpoint capability provided by ARC. Dynamic checkpoint is designed to minimize code changes required to enable checkpoint restart processing into programs that currently do not have existing checkpoints. A good example would be programs that come from a code generator or vendor-supplied application software. Let's look a little deeper into the concepts required to understand how it works. The dynamic checkpoint functionality is provided for COBOL programs only. No other programming languages are supported. Dynamic checkpoints can often be implemented with no code changes required, but this will vary based on specific program requirements. Even if code changes are required, they will be a fraction of the amount of changes required to implement static checkpoint restart processing. Here is a program that reads a record from an input file, updates a database, then writes a record to an output file. In this example, the program has read a record with a key of 109. It has assessed and updated a database record with the same key and is about to write an output record with a key of 109. The logic will then circle back to get the next input record. This is a good example of an input-driven program. In this case, the developer would select the input file as a trigger file by using the following keyword: auto cprsddn equals in001. By specifying a trigger count of 500, auto cprscnt equals 500, ARC would issue a checkpoint every 500 records. The actual placement of the checkpoint for an input file would be just before record 501 is read. For an output file, it would be just after record 500 was written. The trigger is something that ARC can count, such as reads against an external file. There are three general types of triggers available. The most common type of trigger is a sequential file, sometimes called a QSAM file. This would be for programs that process a transaction file to post updates into a database. Programs that sweep through a database can be triggered by fetches against a DB2 cursor or sequential GN calls against an IMS database PCB. It is also important to understand the nature of processing by the program. Since you are allowed to only specify a single trigger for a program, programs that do different types of processing during the execution are often not good candidates for dynamic checkpoint. An example would be programs that contain internal sorts. Those kinds of programs are best managed by inserting static checkpoints into the code. Now, let's look at how we implement dynamic checkpointing. The dynamic checkpoint set of options can be thought of as externalized program code. They should never be specified at the system or global level. Typically, the options will reside in an ARC-related parm lib where the member name will be the actual program name. The member will be referenced in the JCL using the ARC sysndd. Since these options will be developed during the various levels of testing, it is important to include the ARC parm lib members into the established source code maintenance protocol at your shop. It is possible to supply the dynamic checkpoint options via the ISPF panels. This technique is appropriate for some installations, but generally requires additional administration and security access. Let's look at the actual keywords required to implement dynamic checkpoints. Here is a typical set of keywords used to implement dynamic checkpointing. The auto restart keyword tells ARC to dynamically insert the appropriate XRST call into the program. The auto checkpoint keyword enables automatic checkpoint processing. In this example, the developer has selected in001 as a trigger file and has instructed ARC to issue a checkpoint for every 500 records. Before you start testing, a word of caution. Checkpoint processing can be very expensive in terms of CPU resources consumed and elapsed time. It is a good idea to activate checkpoint pacing in the environment before attempting to implement dynamic checkpoint processing. Checkpoint pacing will act as a filter mechanism to minimize the performance impact if a high volume of checkpoints are added into a program. Finally, even though dynamic checkpoint can be activated without a code change, you will still have to test the program to ensure the program will start properly. This concludes the module on dynamic checkpoint. For more information, please visit www.bmc.com.